This is January 04, question 2b. Show from the definition of the joule that an equivalent unit for the joule is a Newton metre. So the definition of the joule comes from the definition for work done. So we know that work done is force by distance. And therefore, if we put units underneath that, we can say that 1 joule of work is done when 1 Newton moves a distance of 1 metre. And if you write the equation down, W equals F by D, then the units are joules, newtons, and metres. And so you've proved that 1 joule is the same as 1 Newton metre. Express a Newton metre in terms of SI base units in metres, kilograms, and seconds. So we know that it's a Newton metre. Newton is the unit of force, and force is mass by acceleration. If I write that just over at the side, F equals ma. And therefore the units of ma are kilograms, metres, seconds to the minus 2 for acceleration, and you're multiplying that by m. And that gives you kg m squared s to the minus 2. Part 3, by the use of units or equations, show the following products also have the unit of work or energy, the product of pressure and volume. Now, pressure by volume is equal to, pressure is force over area multiplied by volume. But if I just rearrange that a wee bit, F times V over A, volume's in metres cubed and area is in metres squared. So if I write that down beneath, we know force is kg m s to the minus 2. And volume is metres cubed over metres squared. And we're left then again with kg m squared s to the minus 2. And that, of course, is the same as our unit above where we said that a Newton metre was kg m squared s to the minus 2. The product of potential difference and charge. Well, we know, we already know that energy in terms electrically is equal to qv. And therefore, if energy is measured in kg m squared s to the minus 2, then qv must be as well. Now you can either just put those in, or you could work out v if you wanted. It does come out as kg m squared s to the minus 2. Part 4, what is the difference between the Newton metre used as a unit for work or energy and the Newton metre used as a unit for the moment of force? Now the difference is the direction that the force is applied in. So when it's used as a work or energy, it has to be in the direction of the force. The distance moved has to be in the direction of the force. So there's a force and it has to be a distance. But whenever you talk about it for moments, there's a force, but it has to be a perpendicular distance. So this distance has to be in the direction of the force, whereas this is a different direction. The distance is a perpendicular distance to where the force acts. And that's quite difficult to explain, and it's quite difficult to decide how you're going to show that.